So now we want to answer the question of when does a function y equal f of x have an inverse? And not all of them do. So for example, if you look at the function f of x equals x squared, so it squares everything you put in it, and we ask, well, what is f of 2? Well, algebraically, f of 2 is going to be 2 squared, which is 4. And geometrically or graphically here, if you go up from 2 to the graph of the function and come across here, you're at 4. Now, if there was an inverse function, I want to ask, well, what is f inverse of 4? So this is putting in a y value, you're getting out the x value. These are the x values that give 4. Well, we know that 2 is one of those values, but also, because we go across from 4 to the graph and come down, we're at 2. But also, if we go across here and come down, we can see that negative 2 would also be a value. So if f inverse of 4 existed, it would have to be 2 or negative 2. But here we would have one input and two outputs. That can't happen with a function. So does this function have an inverse? No. Okay, so f of x squared, no inverse. And you're thinking, well, wait a minute. The opposite of squaring is square root, so this should have an inverse function. Well, that's true if you restrict the domain. So if you say, well, I'm going to consider the function f of x equals x squared, and then I'm going to restrict my domain to be x greater than equals 0. And in that case, yes, our inverse function, f inverse of x, is going to be square root of x. And again, that's going to be for x greater than equals 0. So this one has an inverse because your inverse relation is a function. But if we don't restrict that domain here, if we keep the whole domain negative infinity to infinity, then the inverse relation is not a function. And then I'll also mention, you may remember from pre-calculus or algebra trig in high school that inverse functions, the graph of the inverse function and the function are reflections over the y equal x line. So your y equal x line is the 45-degree line here, like that. And then if I have an inverse function, it has to be a reflection over that line. Well, the inverse of y equal x squared is x equal y squared. So that's here. And you can see that that inverse relation is not a function because every x value that you pick here, you go down and over, up and over. You've got two y values that go with it. However, if we restrict x squared to just be the portion of the graph that's greater than 0, so that would be starting here and going up, then we do have an inverse function, and that is the upper half of x equal y squared right there, the red. So the two red, those graphs are graphs of inverses of each other.